Um, I have been fascinated by early scientific maps and data images, especially those that make the invisible visible by translating abstract data into lines for, well, at least 2 decades now. So it's a long time I have been investigating diagrams, data visualizations, and also historically. And to give you an overview, I have this put in this slide. Historically, the method of visualizing data is quite young, only really gaining momentum in the 18th and then the 19th century. Modern climate research has a lot to do with this, and this is what I have been researching. Such methods produce visual constructs that make it possible to explore relationships and patterns in the object being researched through a method of spatialization. So this is how you could describe data visualization. It's a method of spatialization. And such methods are understood less as, or the results are understood less as finished instruments of thought, but more as exploratory and heuristic organizational tools that use different lines, different types of lines. Here you can see isolines, for example, surfaces and connecting elements to discover and generate patterns and structures and to concisely represent the order that has been achieved. So to, in a way, see patterns in the data, which was hidden in the data. Um, and since at least the end of the 18th century, the potential of such images has been recognized in their ability to real complex information, as, for example, William Playfair said, at a single view, auf einen Blick. This is always the promise of many of the data images, that they are able to reveal complex information, abstract information at a single view. And William Playfair, who I was quoting here, he was in a way the first one who applied the method of lines, data visualization, to the subject of state money in his commercial and political atlas from the 1780s. My talk is structured in 3 parts. After some general remarks about abstraction and also the idea of making data visible, making the invisible visible, because it has a lot to do with our subject, I will turn over to climate change and the idea, what is the difference of climate change perception and weather perception, experience. I will, and then in the third part, show a lot of examples, and then I will try to come to a conclusion, which is also the invitation to discuss these issues with me, because I will talk about a lot of examples which were done before, let's say, the crisis of politics, which means that today climate politics has experienced maybe another backlash, we have to say, but a really profound one. And yeah, I can show you that all these methods, which have been invented, so to say, in the early 19th century, are still valid today. You will see this later. A historical example, which I have been researching about quite intensively, is already alluding to the subject of climate, but it's also a very important example for the history of data visualization. And it can serve to illustrate the visualization of measurement data and climate data in particular. The beginning of data visualization and climatology in 1817 is marked by Alexander von Humboldt's aesthetically very poor and very abstract climate zone map, which you see here on the left, of the northern hemisphere. And this data image, with Europe in the center and America in the west and Asia in the east at the edges, and now I was using illustrative methods to make it more clear to you what these abstract lines actually mean in relation to a map, to a world map. So this data image owes its content to the visualization of averaged weather measurements, that is temperature measurements, series taken 3 times a day at fixed times. And Humboldt didn't only publish his data visualization as it is done today in many times. So normally we only see the product of the visualization, but not the data behind it. But he also gave this very large tableau of data and measurement stations and measurement series, which served as the data grounding for his visualization. And Humboldt drew 6 curved lines, which you can see in his graph or his map, and 1 straight line between the measuring stations with similar temperatures. So it's about similar temperatures, year average temperatures. The isoline method is like painting by numbers. Between the lines, Humboldt made the climate zones visible on the basis of the data available at that time. And thus, these data were only 58 measurement series, which he included in his map. And I have tried to find out which weather stations were behind these data. And you can see that most of the stations were located in Europe, where there was a weather station network already at that time, 1780s. And only a few weather stations in Asia, and South America, and so on. And so maybe one more remark. He drew this image in 1817, but the image depicts weather data from the year 730 to, I think, 784. So it's already historical data, which is depicted in the climate zone maps, because Humboldt thought that the climate was quite stable. And his map helped establish the never satisfied appetite for data, as Paul Edwards called it, and the establishment of thousands of new measuring stations. So in a way, this image is not perfect at all. It has far too, not enough weather stations. The data are really very poor, and the image itself is full of frictions, you could say. But at the same time, what this image provoked is the establishment of these thousands of new stations in order to get better drawings, better climate zone maps. And for hardly any other science requires as many measurements over such long periods of time as climatology. And this is why data visualization and climatology have been developed together since the 18th century. What Frida Nake has termed doppelte Bildlichkeit, double imagery, applies to both types of data images. The images exist twice, namely as data, as code, and as a performance of the code, according to Nelson Goodman. Data images make a code visible. They visualize abstract numerical data, be it weather measurements or sampled pixels. The discursive becomes aesthetic. Raw data takes shape. Only in the pictorial transformation do the craters on Mars, for example, or the climate zones become visible in their location, which were hidden in the bits and measurements before. And we could even go on and think about the binary distinction made by Claude Lévi-Strauss in his structural interpretation of myths. That this transformation of data into image can be compared to the activity of cooking. Unprocessed raw data, as it is called often, and columns of figures trigger an immediate call for transformation into cooked visualizations. Discursive measurements series are converted into aesthetically perceptible forms and thus made accessible to the mind's eye. Considering that Lévi-Strauss, he was an anthropologist, as you might know, regarded cooking as the root of all science, insofar as it involves the fundamental processes of synthesis, analysis, and condensation and practice, the idea of cooking raw data is perhaps not an empty analogy. It is based on the dualistic distinction that Alexander Galloway made, drawing on Willem Flusser's concept of information by contrasting raw data, and Galloway cites the example of data generation by satellites, with its design in the form of visualizations. In contrast to formative information, raw numerical data is unaesthetic. It has no visual form. And we could discuss about this because the tabular form might already be an aesthetic form, but we will come back to this later. However, when formless data is transformed into visualizations, Galloway refers to this as theater, just as a script takes shape in its staging. But this theater can always look different as there is no clear form of information. And for the purpose of this talk, I will continue to pursue the concept of raw and cooked data with the aim of moving from data to digestion. This is because the culinary metaphor of raw data goes hand in hand with the idea that large accounts of data, which are due to the increased appetite for data, are difficult to digest. In order to overcome this difficulty in digestibility, the data must be transformed into a different state. If we take the word raw in relation to the state of food literally, this state can be tentatively related to the anthropologist schema in which cooked stands for better digestibility. And such a metamorphosis is helpful in turning data into knowledge that enables further insight and is also easier to memorize, to transport, and to reproduce, and to be an immutable mobile, as Bruno Latour has argued. And I would like to to also give you two more concepts. One of them is, I would already call it a classical concept, Sichtbarmachung, making visible, which Hans-Jörg Reinberger, historian of science, suggested for distinguishing between forms of reproduction, Nachahmung, or representation, Repräsentation, that suggests a mimetic or object-oriented character. I here give you the example of King Louis on the left, which would follow this idea of representation. And on the other hand, there are many images which we now might call operative images, but which follow a different idea of what an image makes actually. And this is Sichtbarmachung, making things visible. And in contrast to the idea of reproducing things and the resulting similarity to them, visualization aims to emphasize the productive and constructive aspect of image production in scientific practice. Numerical values, complex phenomena, or invisible symptoms are only made present, visible, and manageable through images. And this is summarizing these concepts of making, this quote is summarizing these concepts of making visible, which goes back to the iconic turn and a long discussion from the 1990s on and the early 2000s about visualizations, which are described as a fundamentally new paradigm of visibility in the scientific and technical field. And this is where we can also locate data visualizations. And coming back to images which, well, are using data visualization, like many of the most important and even iconic graphs of climate change. And here I show you the most important graphs of climate change and also which prove that climate change is actually human induced from the research of the last decades. We could also turn to teaching in textbooks on visualization, where we find the most important criteria for high quality data, visualizations and diagrams are the principles of expressiveness and effectiveness. And expressiveness or clarity depends on the degree to which a visualization shows all the relations found in the data and only those relationships. And effectiveness, on the other hand, the efficiency in terms of the relationship between means, averages, and results, refers to the comprehensibility of a graphic. So this is the idea in visualization design, computer graphics, about expressiveness and effectiveness. And so these concepts are about the best possible relationship between the graphic representation, which might be a curve, a map, and our perception, which can vary depending on the topic and data. And the graphs I show you here are the Keeling curve, which has been drawn by the metrologist Keeling since the year 1958, and it shows the increase in CO2 in the atmosphere since the year 1958. And you can see the change, the constant change, because humans emission CO2 into the atmosphere. And another graph which got a nickname, the hockey stick graph, by Michael Mann and his team from the year 1998. And here in the version of the Intergovernmental Panel on Climate Change report from 2001, this graph is the second graph in the middle, is based on data of tree ring archives. It's proxy data, and it was very much discussed and even disputed because it was given as a proof by the IPCC that climate change is human-induced, and you can see rising temperatures even before the age of, not even before. You can see that the temperatures which rise since industrialization in the 19th century are in a significant difference to the ages before, since the year 1000. Or then I also show you climate history, 600,000 years of climate history, a data graph again, very simple curve, we could say. This is a curve, how it is actually depicted in paleoclimatology, where you can see, again, based on proxy data of ice cores, how paleoclimatology uses little bubbles of air which are included in ice cores, which they drill kilometers down into the earth. And by this, you have a natural archive, and you can see by proxy data methods how the temperatures might have been during these times and how the CO2 levels have been. And this graph actually is written from right to left. So it's not in our convention of reading depth. You have to pay attention to this. And I wanted to show you these very iconic, I would say, climate graphs, which are still not known to all of us. And I will now come to the idea of climate change and the perception of climate change, because this is a key argument for the works I will show you in the second half and the third part of my talk. In climate psychology and cognitive psychology and social psychology, there's a lot of research which has been done about the question why people don't act as much as the knowledge would make us think the people would act. And one of them is Per Espen Stoknes, who wrote this book, I think 10 years ago already. And he proposes 5 perceptual barriers to the climate crisis. So, and the first one is already alluding to the topic we are dealing with in this lecture series. It's the problem of distance and abstraction. The climate crisis is too far away and abstract. And this is something people were writing 10 years ago. In many books, you could read this argument. I have followed this argument myself. And in a way, this is also what I would love to discuss with you at the end of my talk, if this is still the case, or how we could think about this problem of distance and abstraction. The climate crisis is too far away and abstract in the times we live now. I won't go into detail for the other obstacles, the other barriers to the climate crisis, although they all deserve a lecture. So abstraction and abstract knowledge, this is like a conclusion after the part one. We can say that visualization can make abstract data visible and by this more graspable and concrete. Scientific visualizations are still more abstract than, let's say, figurative paintings and photographs. So the images I have just shown you of climate change, they are still quite abstract, I would argue, although they already made abstract data visible. And then climate stays abstract on even three more levels because A, scientific knowledge is abstract to many, which guided the deficit model in climate change communication. It's about teaching people how to know more about climate change and what do you need to know about tipping points and so on. This is a not question of knowledge, of understanding abstract knowledge. And B, because climate is an abstract research object in itself, it is the average state of the atmosphere at a particular place or in a particular area over an extended period of time. And I will show you a slide to go more deeply into this argument because this becomes political. And then climate change stays distant because it unfolds in the future. It has this character of a slow violence. And so there are many layers why climate change is abstract and distant, I would say. I will skip this slide and go directly to this one, which tells us more about the ontologies. Climate is not weather. This is something many learn at school, and this is also something we have to differentiate if we do climate science. It's a scientific definition which is 200 years old, and the terms weather and climate are closely related and incompatible at the same time, because both describe changes in atmospheric variables, such as air temperature, humidity, and so on, but they do so over different times and spaces. And so one could say climate is what we expect and weather is what we get. So weather is something we experience, like the snow on the street or the cold outside or the heat, but the climate is an average product of an averaged object made through many days. It's many days, and in the scientific definitions, it recommends even a large scale of 30 years in order to speak about climate. And I would like to introduce you to this argumentation by the US anthropologist Peter Rudyard Gold, which he already wrote about in 2013, but I think it's still very valid. Because in his article that provides aspects worth considering for our question, he claims he asks about who actually claims to experience climate change. And Rudyard Gold had already looked in 2009 at how people on the Marshall Islands, a group of islands in the Pacific, perceive global warming. And he gave his essay the title, "We Saw It With Our Own Eyes." And then, right at the beginning, the anthropologist quotes several scientists along the scientific distinction between climate and weather. For example, Mike Hume says, "No one can see climate change or feel it happening." Or a correspondent for the BBC says, quote, "You can't really see global warming," or "People don't directly experience climate change." And alongside this, the anthropologist places contradictory statements from people who claim to be directly experiencing climate change. Koloa Talake, a former prime minister of Tuvalu, an island state, already said in 2003, "Islands that used to be our playgrounds have disappeared. We have seen it with our own eyes." Or Alan Parker, a member of the Chippewa Cree tribe, and director of the Northwest Indian Applied Research Institute, wrote in 2006 in a report. Indigenous peoples in the Arctic and subarctic are already feeling the catastrophic effects of warmer temperatures from melting sea ice. And so by accepting only the scientific definition of climate, which is an abstraction, and which puts the perception of climate exclusively in the hands of researchers with their mediated methods, many perceptions of climate and climate change are excluded. And the question of who is actually allowed to claim that he or she is aware of climate change therefore conceals a power political core that can be extended to the inhabitants of many regions. And I will get back to this at the very end of my talk, and I will now come to the third part and show you quite a few examples of how actually artists, but also scientists, data visualizers try to make data visible, climate change visible differently, and before we then can get into a discussion. Yeah, this is something I also wanted to pay attention to, that even abstract climate information can cause emotional reactions such as climate grief. And this is something I think we have learned since the Fridays for Future movement, that there also in Western societies where maybe we don't see and experience climate change as heavily already in our regions, still these abstract climate information can cause real emotional reactions. And this is why we have psychologists for future. I just briefly wanted to mention this dimension. First example is from 2007. It's called Champ d'Ozone. It's red coloring. Sorry, I didn't translate the title. Red coloring, which changes. It's a glass window, depending on the current values of the environmental office in Paris. But the color of the glass, which changes, gives no clear assignment of values or danger or anything. So the visitors have to find out for themselves whether the rust red sky is particularly dangerous or rather the green. And in this way, on the one hand, an invisible condition of one's own environment is made perceptible. And for a long time, there was this argument, if we could only see CO2 emissions, maybe people would do something about it. And the artist duo Hehe is alluding to this idea, I think. The second example I'm showing you here is from the year 1 year later, 2008. Artist Yves Mosher read a scientific report on impacts of sea level rise in the New York City metropolitan area. And then she drew these lines into a city map and rented a chalk wagon, something which you use to mark the floor of football grounds, for example. And she walked around her whole neighborhood for many kilometers through Manhattan and Brooklyn, New York. And she ran her car over 100 kilometers of the New York Bay region even, which is particularly vulnerable to floods and storms. And later she also did this performance in Miami and Philadelphia. And she used the line to mark the elevation line of 3 meters above sea level, which is considered critical for future century floods. And what the artist drew into the city's reality were the abstract tables, curves, and maps, which climate scientists had calculated due to global warming. And she didn't put her artwork into a museum, but wanted to actually perform it in reality, and by this bring these abstract lines into the reality of a city. And when later Hurricane Sandy crashed into New York, actually people who had seen this performance, they were quite aware why actually their buildings were flooded. And I will now show you some, well, give you some sonifications. We will listen to them together. If I still have the time, yes, I do. What you can already hear in the background is artist Katie Patterson's work, also from the year 2007, which was a year in which a lot of climate artists' artworks were commissioned, actually. And this artwork, which you can see on the top left, is called After Three Glaciers in Iceland. And the sound recordings from these three glaciers were pressed by Katie Patterson into 3 records, which were then cast and frozen with the melted water from each glacier. And the ice discs were then played simultaneously on 3 record players until they were completely melted. So this was a rather conceptual work on climate change, but also on the permanent loss of glaciers, which you cannot rewind in a way. So you can listen to the records while they are melting, and also the sound, of course, which I can't illustrate to you now because I only have this snippet. But if you go and see this artwork, you can hear how the sound changes from water sounds and melting water drops by a hydrophone into noise, which is the effect of the melted record, still in movement. And on this slide, you can see many other sonifications, and I will play 2 more now. One is by Natalie Miebach, and she is a very interesting artist in regards to the question of making data graspable. On one hand, you can see her data sculpture on the right. And on the other hand, she does notations of weather, for example, a hurricane. She did the recording of the data measurements by herself and then drew these notations, which she then gave to musicians and asked them to interpret the data with their instruments. And here you can listen to a quartet of string instruments, and I will play only the first 2 minutes. I will turn it down now. The piece is 17 minutes long, and when you look at the graph while listening to these 17 minutes, you will find actually when the hurricane really hits down onto the coast where she did this recording, because this goes together with temperature and pressure changes, abrupt changes in temperature and pressure. And this is what the instruments then also perform. And of course, this is a very artistic and improvised music piece. So if we talk about expressiveness and efficiency of data in relation to visualization, we can ask if these concepts are also true for sonifications of data, this is what the piece is based on. And I will give you a contrast piece in order to think more deeply about this relation of data and sound. Sound is actually discussed since a few years as a different way of approaching and relating to the world and also to ecological issues, because listening has a power which is different to visualization. And this is something which a lot of artists who use sound and work on ecological crisis now do in their practice. The piece I will show you now, or make you listen to, it's not a piece actually, because it doesn't even have a title, because it's more an explorative way of using from scientists who used sound and again string instruments, but by a MIDI, so they are synthetic sounds, and they don't have an approach as artists to their sounds, as you will see, but they really wanted to use sonification in order to understand their data set differently, because they had data from the Southeast Alaskan forest, which has been affected profoundly by climate change during the last decades. And you can see the yellow cedar declining. It's a place in Canada. And what you will hear now, it's a very short piece. Each note represents one tree, a total of 2,000 trees, which they datified. The pitch and the strength of the stroke correspond to the height and diameter of the tree. And the key is in D minor. This is their decision, actually. There's nobody forced them. It could also have been major, anything. And the period is over 100 years. And we will listen to this now. It's, I think, 1 minute long. And actually, you would need to listen to this piece several times to really hear the patterns. But both the researchers said with this data sonification, you can handle a lot more dimensions if you're listening to data than looking at it. I will again stop it here. As you can experience, the sound patterns change. And I think it's a very different approach in terms of expressiveness and efficiency about in relation showing the data. But also you can think about how these music approaches to climate data also relate differently when it's about relating feelings to what you hear, actually. Oops. I will now swap a few slides which make climate change graspable, because this is, of course, the third concept next to visualization and sonification. It's also data sculptures are there to make climate change graspable. Like here, this one project of carbon topologies from the year 2022. They are artists. It's an artist group from Great Britain, and they were mapping locations, amounts, and flows of CO2 resulting from the activity of the global economy from the 1970s to the present with this globe. And here you can see actually what the ship lines, how they emission CO2, and it's a very different concept to thinking about CO2 as a historical evolvement of economy on a globe. And actually, it's really hard to then locate Europe, America, and etc. when you're not familiar with these ship lines. And it's a very different way of making data understandable through the concept of habitualization. And if you live or visit Berlin, you can also go to the forest, to the Grunewald, where actually this idea of making climate change data graspable through sculptural approaches has guided this exhibition, which is called Wald Berlin Klima, an exhibition in the forest built in 2017, where you will see many of such sculptures, data sculptures, which try to really make data, for example, like how many hectares of forest do we need to compensate CO2 emissions of one Berlin citizen? And this is half a hectare. And then you can see how many of these trees would be half a hectare to just compensate your own emissions. And also at the Venice Biennale, when there was the German pavilion was done by Nicola Borgmann, Elisabeth Endres, and Gabriele Kiefer and Daniele Santucci. And they had this exhibition on stress test. And this is a data sculpture for the concept of heat islands. And they used sticks of wood, which have a different height, to show you actually the high risk of heat islands, which is which is caused by the density of buildings and concrete streets in cities. And as you can see, the heat island effect is really a drastic difference in comparison to the countryside around cities. And they also chose a sculptural approach to data. One of the last examples is another art piece. In this case, it's the famous artist Olafur Eliasson and his work Ice Watch. And he had transported a lot of ice from Greenland to different cities. In this case, it's Paris and Copenhagen. And the interesting thing is that people actually were interacting with these ice blocks quite intensively. They really wanted to touch it. They sometimes nearly creeped into the melting ice of Greenland. And this is an interesting artwork also in terms of making an abstract, distant development concrete in experience and making it graspable by bringing ice from distant locations from the northern zones to the temperate zones, so to say. And I put this painting by Caravaggio next to it, the Incredulity of Saint Thomas, der ungläubige Thomas, which is also this idea of seeing is believing. Sometimes it's not enough. Sometimes it has to be touching is believing. And maybe I will stop here, and so we can have a discussion. I won't go into this example now because I'm running out of time, but I would like to come to my conclusion. So from knowledge to action has been a long time something people followed during the last decades in order to understand politics and to also say that climate research is, of course, very important, and it's so important to understand climate change. But I would say to the history of climate change, politics has proven that there is no direct path from knowledge to action, and that this ideal, in a way, we are posted, and we have to acknowledge that there is no direct way, or maybe even no way path from knowledge to action, no direct path. That's what I want to say. But this sentence then was also changed. Maybe there's a way from perception, from sensing to action. This is what the artists propose who I've shown. How much concrete experience does it need to act? Today we can experience climate change in many spots, not only in the southern or northern regions, but also in the temperate zones already. Still, action with broad impact is not taken. And the third paradigm is from feelings to action, which is discussed a lot, has been discussed a lot in the last years, because feelings are a strong motivation to act, but also stand in the way. That is when believing, for example, in the way of believing, as cognitive psychology and many other disciplines have shown. For example, ignorance, strategic denial, post-truth, the idea of post-truth, all these developments can go also deal with feelings a lot, but they don't show us that feelings lead to action. So we would need to rethink about it. What does it mean to live in an era of inaction and denial today, of post-truth and strategic doubt production? And this is how I see our times. Are aesthetic methods which render climate change graspable enough at all? The ones I showed you from the years 2007 to the 2010s. While at the same time, a lot of powerful agents want to push climate change far away and let it stay abstract even, so we don't have to care. So I would say the ignorance and the strategic denial is so strong now that actually it's for people who want to follow, who have the idea of strategic climate change denial, climate science denial, they are happy if it stays as abstract as possible, so we don't have to care. And with this, I would like to end, and I'm looking forward to the discussion.